Okay. The power was off, so to for what I'm talking about. Okay. So going back, for microservices or SOA, the idea is just introducing some extra overhead, because we need to break the system down into multiple services, and each service by itself is an application, a sort of standalone integration application that integrates with other part of that the system. So by doing that, we are introducing overheads, of course, because now you need to define, for example, the RESTful API, and then also there's usually like even performance network overhead because of that, and then certain things might need to be implemented or mapped, right? For example, if you are simply a single Ruby on Rails app, then the model only need to be defined once, and it's automatically mapped to the database with the help of Rails. But if you were to do it in a, for example, microservices way, then you need to define the model in Rails and then expose it in a RESTful API. And then in the other part of the application, you need to request for that. For example, it's a JSON API, then request for that JSON form of data, parse it, and then remodel it to whatever that's relevant in the other part of the application. So there's definitely extra overhead by doing that, and also it's going to be a little bit more trickier to roll out updates because if the application is one code base, then you just you can bundle all the changes together and then release it at once. But if it's it's a multi-part application, like for example, if you want to update the user service, then you need to make sure all the services that's dependent on that user service also will still stay compatible with the new version. So here we can still borrow some of the ideas we mentioned earlier in the course, where you could do stuff incrementally, right? You don't have to destructively modify the APIs. You can still have all the APIs stay in the same way with some additional APIs or additional fields, but just don't delete anything already there. And then you release it, then you update the other part, and then go back to update to delete some of the used ones. So it's still feasible, but it still just makes things a little bit trickier to do. But the trade-off here is by introducing some extra overhead. Really, we are looking at making each individual service, each individual component of the application to be able to fit the two-piece team. Because with an application become too complicated, too big, it usually will require a bigger team. And once the team gets too big, there's also the other kind of overhead happening, which is communication, and the risk of miscommunication increases as well. So here, by doing microservices or SOA, really we're just introducing some overheads in terms of engineering, writing executional code, and making sure the integrations are compatible with each releases. We are trading off that for the potential overhead and then potential risk of miscommunication once the project and the team gets bigger. So the idea is usually if you can stay with the one piece or monolithic approach, go with that architecture, and once the team gets bigger, and once it exceeds 2 pizza team, then break it down into microservices or SOA. Or if at the very beginning you know it's gonna be already too big, then at the beginning you can already go with microservices. But otherwise, usually the idea is to go with mono whenever possible. Okay, next then we were introduced the MVC pattern and Rails. There's not really too much to talk about. That is usually for conventional web application. MVC is usually always right, and Rails is usually always a great option out there. But what I want to say is, which we talked about it when we talk about the framework, is just repeat that argument actually. So when the question arises, for example, a new project is initiated, then we need to make a decision which framework should we use, which language we should choose. And usually the advice is to decide the framework first, and depending on the framework, the language is automatically chosen for you. And then to choose the framework, a few factors should be considered. The experience of your team with that specific framework. If all of your team is very, very experienced with that framework, it might be a good option, as long as the framework itself is a good fit to the project. Because with unexperienced frameworks, usually mistakes can be taken, and some hidden feature you may not be aware of and later cause issues. The other factor would be how easy it would be to hire someone to add to the team. So that's the reason why usually you see some team would prefer using PHP, prefer using even when it's a CMS, prefer using like WordPress or some of those popular CMS out there. And one main factor for that is usually it's really easier to hire someone to add on to that team or even to replace someone. But if those factors aside, then the next major factor would be the feature and the ecosystem of that framework and then the language. And here I have some general list of the most popular ones, and those are the ones I have at least some experience with. So in general, Ruby on Rails, I would say is my de facto choice for conventional web application. And then it's also a powerful tool for pen testing just because of the software which is called Metasploit. It's another framework for pen testing. It has many built-in and then extensible plugins to test vulnerabilities of applications. And then some of the DSL domain languages. For example, for DevOps, there's our configuration management, there's Chef. So if you want to use Chef, you would need to use Ruby. And also if you're developing a domain-specific language, Ruby is also almost always a great choice, just because of the syntax of this language. It makes it really easy to develop a DSL. Because the syntax is really flexible. All right, and then For stuff like PHP, although PHP has evolved a lot since its beginning, but I personally still would choose it for a templating language. So it's still pretty good in terms of templating the web application. And then some of the powerful and very popular CMS out there. So if I were to do a CMS, that might be a good option to go with PHP. Python has a really strong community behind it that does data science and machine learning. So, for example, like PyTorch, I think it is by Facebook, and TensorFlow by Google. Those are great machine learning frameworks for, deep learning. And the other data science packages, such as NumPy, SciPy, and then there's NLP, Sklearn, and all those libraries out there. Most of those are in Python, and then you probably cannot find anything equivalent in other languages. Although you can probably port it to other languages, but it's just more convenient to use something already there, right? So that's usually the great thing for Python. For JS and Node, if you want to build some event-driven application, or if you want to do something for web front end, so that's usually the only option for you. So for web front end, especially like building a SPA or single page app, then you kind of have to use some of the JavaScript frameworks, like Angular, React, or Vue. Those three are the most popular ones. And then for event-driven applications, like for some backend, if you need to use like socket, if you are building some real-time backend application, then Node might also be your choice. Next, Java. Usually, if you build Android application, you probably have to use Java unless you go with Kotlin. Also, Java has a strong community for MapReduce. So if you are building a highly scalable application, then usually you're looking at MapReduce for unlimited scalability. Then you probably would go with Java because it powers many of the tools like Hadoop and all that. Although these days people still use Hadoop, but usually just use Hadoop for batch processing. But for streaming, you might be looking at some other tools, and then you might look at some functional programming languages like Haskell, Clojure, Scala, that kind of thing. All right, next, if you're building something performance critical, but usually those are like really low level stuff, then you probably need to use C or C++. For example, once I had experience writing a plugin for a reverse proxy middleware. So that was written in C, and I have to use C for that. Next would be Go. Go is usually good for high concurrency applications, and designed by Google. The primary goal of designing the Go language is for high concurrency. So if you're looking at building something with that requirements, you might want to use Go. C# or Swift for iOS native, Lua for game scripting. So if you're going to develop a game, maybe you will need to use Lua. Flutter, which is another mobile application framework published by Google, which it uses Dart. So yeah, depending on the application you're trying to build, based on the requirements, you will see what would be the best framework or language that offers the feature and the ecosystem that has the best match. Okay. Next, we talk about BDD, and then the first technique we introduced was user stories, where by using a card, like either physical or digital card for each user story, we communicate the goal of this feature, right? We have as a user, for example, or as an administrator, as an accounting person, whatever. So that's the scenario. We define a scenario. We kind of build a persona, like who's virtually the user that's interested in this feature, right? So we say as someone, in order to do something. So here we communicate a goal or the primary reason for this feature. So that so in order to do something, how do we say that? As a user, in order to do something, so that we can do something. Actually, whatever, I forgot the keyword. So, so basically we define who's interested in that, what's the goal of that, and then a brief sentence of what we're trying to do with this feature. And then it's further expanded with those scenarios, like given something, when I click something, I should go somewhere, I should see something, right? That's a user story. So, and also user story reminds you it's independent from the methodology. So even with waterfall, you can still use user story, right? Because at the beginning we still need to plan. So during the planning and designing phase, how do we produce documents, right? So there are other standards to produce documents in waterfall, but still you can use user story to produce that document during the planning phase. So it's actually independent. And then we really introduce this technique to define the desired behavior, and then to help the communication between technical person and a non-technical person. So that's user stories. Next, we introduced Storyboard or wireframes, where it's just a lo-fi job of the user interface that would basically give the non-tech people an idea of how the UI will look like and how the user would interact with the UI, hence user experience. And again, this technique is still independent from methodology, so you can still use it in waterfall, in agile, in extreme, whatever you choose. So usually it's paired with user stories, but also depending on, like, if you have really limited time by doing one another, it's also an option out there. You could just do user story, or you could just do storyboard. That's also the option out there. Next, we will introduce point velocity or the point system, in the hope of making better estimate. Then, depending on how accurate you would be able to make estimate yourself. That would decide, if the point system would be beneficial for you. Okay. Then we were introduced acceptance tests, or specifically with Cucumber. So acceptance tests, it can be actually independent from user story, but usually they are combined. So once the user story has been produced, with Cucumber, you turn that user story into the actual tests, and then we call that acceptance tests. And then it's a convenient tool to translate behaviors specs to the actual tests. And then again, that's the same thing. It's independent from methodology. So even if you were to do waterfall, you want to test after the fact, you can still do Cucumber tests, as long as you have the user story in place, right? The only difference is in Agile, you do the user story first, and then you convert it to translate it into tests, and then you write the code. So there's the trade-off here. You need to decide yourself. Next, TDD, or test-driven development. So the test itself, so whether test is first or test after the fact, the point of testing is what we've mentioned earlier, is to ensure the quality of the software that delivered, and to improve long-term productivity. So then the question is, how likely the stuff will change. If that specific part of code will change a lot, like we made an example of A/B testing. So by doing A/B testing, we already know that one of this feature will be dropped, or one variation of the feature will be dropped. Then we may want to skip testing for that. And then once we finish, the A/B tests and know which feature we will go with, then we write the test after the fact. So sometimes that would make sense. And also, do we do test-driven TDD? Do we test first? By doing test first, we make tests mandatory. And then by writing tests first, we sort of also make design mandatory, because by writing tests, we need to think about interface first, right? We need to think about, how this class would look like from external perspective, how I would consume the API, consume certain method, and then we will design. Then this method needs these arguments to be passed in it, stuff like that. So by doing TDD, we kind of also make design mandatory before implementing the code. Next, it also TDD also serves as a early code smell indicator, as mentioned in the course. Given the time limit, I will just skip the detail of that. So the trade-off here is really sacrificing short-term productivity, right, for long-term productivity. Because by writing tests, we ensure that code hopefully has less code smells, is designed better, and then we avoid potential bugs because we have tests in place. But by writing tests, we are basically giving up time that we could be writing actual code. And then if the project itself is disposable, or there has been a plan to dispose to replace the system at some point down the line, then there is a good argument to be made that, do I really want to write tests, spend time writing tests, or do I rather just write the code faster, spend more time on that? in order to gain more short-term productivity. So that's the trade-off here to be made. And again, that's something independent from methodology. So even in waterfall, you can still actually write tests first. But usually you still have the QA process later in the project life cycle. Okay, next we talked about dealing with legacy code, and then here's the definition. Still, you can have your own opinion on that. There are different definitions on legacy code, right? You can. So first of all, legacy code, at least it should be working code, because if it's not working, not being used, it's probably just trash, thrown away. But then with those working codes, sometimes it doesn't have any testing, and we call that legacy code, and it actually makes sense because without testing, it's very easy to break it. And then we can define legacy code as code that has been produced long ago. With that, the problem is even though it's functioning, it's gonna be difficult to update it, right? For example, if a code is written 10 years ago, it might have been written in Rails 3, right? But nowadays Rails has already been updated to 6. And then there's for sure backward incompatibility introduced, and also considering all the gems and all the dependencies involved. If I want to update it, it's just gonna break it. So we could also call that legacy code, and then there's a good reason for that as well. And also by having something really outdated, it's also difficult to find documentation for that. So for example, today, if you want to find the documentation for Rails 3, probably you won't be able to find any helpful information, even with the help of Google. And then we could also say like the code is something produced by someone else, especially for things that doesn't have any documentation. And if it's produced by someone else, it can be legacy coded, and it can be difficult to deal with because you don't have understanding of the baseline, even the baseline of the code, right? You don't really know how it's supposed to be behaving, and then that's also a good reason to call it legacy code. So then, that's about legacy code, which we've introduced techniques to handle that, which is here under refactoring. So the first step is always to set up some sort of environment, safe environment, either by cloning that or setting up a development environment, so that you can just step it all around and then break it, and then just figure out how this application is supposed to be used, and then gather as much information as possible, and then write some characteristic tests. So that's really the essential thing to do when it comes to your refactoring legacy code. So hopefully with so then if we look at legacy code from this perspective, that would mean if a code base does not require any refactoring, meaning it already has like a easy documentation that help you set up the development environment, and it has enough information describing how it's supposed to behave. For example, by having user story, by having cucumber tests, by having unit tests, where you don't even need characteristic tests. Then by looking at the tests, you can understand and use tests as an example of the usage of the system, then right, those code does not have to be refactored in that sense. So then those code would not be called legacy code, right? So here the technique for refactoring is really for legacy code that's missing some of these. Either doesn't have any documentation about how to set up development environment, or doesn't have any documentation or testing in place so that you don't even know how it's supposed to be used. You don't have any unit tests, so you don't have any example of how a method is supposed to be called, stuff like that. So refactoring is really the technique to bridge these missing pieces. If you have to work with a code base that's missing all that, how do we tackle those step by step by reintroducing all these essential parts so that you can safely modify the software. Next, we will introduce some code smell measurements. You can always just look up those documentations. There are services out there, Code Climate, there's Jam, Code Cov, and then I've talked about linked tools. Those are great stuff out there. So just be aware if you are interested in that, you can just explore those solutions. Then we talk about two-piece team, and actually it pairs with what we talked about earlier regarding SOA or microservices. It's really a trade-off of, because we have to comply with two-piece team, so we have to break down applications into subsystems, or even go with microservices approach or architecture, and then by doing that, introduce overheads. But we are trading off that, so we're introducing those overheads to minimize the risk of miscommunication. So that's really the point. Next was about version control and branching, how to use Git effectively, and then we were introduced a good way of managing branches is basically have a always safe master branch plus branches for each feature. That's work in progress, and possibly and then possibly optional branches for each release. There are some other practices out there, and unless you get really that big, usually for a small team, and then I would say in most cases you will be working in a setting like that, then a branching strategy like that is usually effective enough and then easy enough to manage. Next, we were introduced the idea of continuous integration. The idea is basically have all those testing we've written to be automated. So having a CI system, and then there are also solutions out there like Traverse CI, and there are really a lot. So basically, we are introducing a service that automate all these testing for us, and then pull those results. How many tests has failed? How many? How the measurements looks like after code change. Does the code get more smelly, right? Any feature was broken, because even with code review without automated testing, like sometimes it's even hard to notice syntax errors, right? Because sometimes syntax error can be as simple as missing a semicolon. For Python, it can be as simple as using tabs instead of spaces, right? For some languages, it might be as simple as using a wrong character. So for those syntax errors, even with code review or even with pair programming without testing, it can be hard to notice. So then with CI, at least, if we check syntax errors, and then great would be we have all the tests in place and automatically run all the tests. Then with every single commit, we have an automated report of what's broken and what are not broken, right? So that's the idea of continuous integration. And I would say, if you have testing, then always have a CI, because otherwise you're just wasting your tests. And then when you implement CI, and usually CI is not that difficult, that not that time consuming to implement. So with CI, you're basically fully utilizing the potential of testing, or at least for a product that doesn't have any tests, I would say at least set up some CI testing just to check the syntax. And I've seen, especially for something like PHP, I've seen programmers just, introducing bugs, syntax errors every once in a while by making mistakes. All right, next we talk about deployment. So deployment should always be one click or one command. Otherwise, it's always something will go wrong, and people always make some mistakes. And then once you have this deployments in place, that one click, one command in place, you might as well just implement continuous deployment or CD. It's basically automate the deployment process. Sometimes you can go really extreme, where for everything that passes CI, it will automatically go to CD for deployment. Otherwise, you may want to hook it, integrate with like the Git platform, if it's like GitHub or something. Like once you merge the pull request, that's automatically deployed to production. And usually that also doesn't really require too much effort, as long as the one click, one command deployment is in place. And there we introduce the idea of PaaS versus IaaS. Whenever possible, use platform as a service, because usually those solutions have that deployment command built in already. Otherwise, with infrastructure as a service, you usually have to figure out by yourself, and you possibly need some tools like Chef, Ansible, that kind of thing. All right. And then when we talk about DevOps, we were introduced the measurement of Apex, where it's really a good measurement that's telling you is your application too slow, and then which part of the application is too slow, and the importance of monitoring. So if there's only one thing in the operation world you can do, then that would be monitoring, because monitoring can tell you everything. And then that's the foundation, the cornerstone of everything else we talk about in DevOps. Okay, since actually DevOps is a pretty recent lecture we had, I will actually skip some of those, like how to deal with releases that's not compatible with earlier release, how to improve performance by implementing caching, right? How to optimize database queries, all that. I'll skip that. And then lastly, a design pattern. And I would say for design pattern, if you don't remember anything, that's totally fine. Because it's really an experience-based thing. So you need to have some experience, spend time reading code, writing code, and then if possible, read good code by exploring those popular frameworks, popular plugins, popular libraries. Usually you will have some good idea of design patterns. And it's really about developing a taste of your code, and then having that instinct. And then going back to some of those textbooks, have some a good understanding of different patterns, and remembering this solid principle. And once you get to that point, design patterns should start to make sense to you. But otherwise, just don't spend too much time and effort going every single detailed design pattern and try to memorize it. Just no point doing that. And then lastly, project management, where the project is usually broken down into phases. Same goes to agile. Then each iteration goes through these phases where you have initiation, planning, and execution. And then you have a close phase where everybody reflect on previous iteration or the entire project. And then we've discussed our role, but since it's the last lecture, I won't repeat that. Okay, so that's the review and recap of everything we've learned in this course. I will share this note in our chat room, so that if you want to review it, you could also just go through this list. But otherwise, we've concluded this entire course, and hopefully this course is helpful for your entire career in IT. Alright, and it was really a great experience learning and then exploring this topic with all of you. Lastly, make sure you finish all the homeworks and do your final. And I'm strict in terms of the grading and scores, but also I would say I'm graceful in terms of how I do the grades. As long as you put in the efforts, I will give you the good grade. And then for the online students, remember to leave your comments on those recordings on YouTube, and that will be recorded as your attendance. Alright, so again, I will always be available. You can reach me via email or Telegram chat. So if you have any question, not only just this course, if down the line when you do IT projects, or just have any question in terms of IT technique, feel free to ask me. I should always be happy to answer your questions. Alright, so we'll conclude our course for this quarter, and hopefully I will see you again in other courses in the future. Bye bye.